but you want to do them carefully. A cup of coffee. Let's see what this looks like. If you want to come a little closer, are we recording? I'll let you know when.
Okay.
Let's work with this idea of a cup of coffee and how much sugar you put in. First of all, you have to know the weight of the solute. I've been talking about solute and solvent in lecture, and it turns out that 342 grams of sucrose, and there is table sugar, sucrose, 342 grams, that's what you're looking at. This is approximately, give or take, about 7 level teaspoons of sugar. Is that how much sugar you would put into 1 cup of coffee? That's pretty sweet, isn't it? But we're not going to put it into 1 cup of coffee. We're going to put it into a liter. And here's a liter. So I'll give you the idea of the volume that you're dealing with. If I pour this in here, I'll do this fast and sloppy. Oops. Mix it all up. After it dissolves, you still have 1 liter. You haven't changed the volume. That's the nice thing about soluble solutes. They go into solution. They don't change the volume. So now you have a 1 molar solution of sugar water, right? Or coffee if you're talking about that. Now next, we want to figure out, well, if this is a 1 molar solution, how many grams of the sugar would be put into this cup? This is 150 milliliters, a standard serving of coffee. So again, I did the calculation up here, and I'll take you through that calculation again before we finish, but it's pretty straightforward. You would take approximately 50 grams of sugar in your morning coffee if you have a 1 molar solution of sugar. You all know how sweet that would taste. What if you like 2 teaspoons or 3 teaspoons? You might be taking a 2 molar solution or a 3 molar solution. You see how this would work? The more solute you put in, the higher the molarity becomes. Now let me show you visually something to help reinforce this idea of changing concentrations. So you want to come a little closer because I want to have you see some colors against a white background. Some paper towel. Ms. Melita, could you, over here, could you grab some paper towel for me, please? You can all see this, can't you?
Yeah.
This is a very concentrated concentration of, it's a potassium permanganate we used?
The crystal violet.
Crystal violet. And it's got a very dark purple color. I'm going to call this a stock solution. Let's pretend this is a 1 molar solution. A stock solution, 1 molar. Got it? It's very high concentration. Now I want a 10th molar solution. I want a 10th molar solution. How can I get a 10th molar solution? And I'm going to use an instrument here. This is a pipette. And suppose I want to draw some liquid, a known volume of liquid. You're all going to get a chance to use these pipetters during the semester. It's no big deal. I'm going to measure out a certain volume of liquid. Let's say it's water. You forget the sugar in there. Now here's the question I want you to think about. How much water do I need so I can dilute this concentration down to a 10% level? Right now it's 1 molar, and I want 1/10 molar. So how much water do I need here? Think about this. I'm going to take a little bit of this and put it into here. Anyone want to guess how much water I should put in here?
10 drops?
Drops? No.
10 something.
10 something. Yeah, that's a safe answer. Well, think about this. Who in here cooks? Did I ask you this before? Does anyone in here cook? Seriously. If you're a good cook, what's a sign you're a good cook?
Eyeball them.
What's a sign that you're a good cook? Serious question. People want more of your cooking, right? What's a sign that you're a bad cook? Oh, no more for me. I'm full, right? Well, good cooks know a lot about proportions and percentages and cutting recipes You know how to cut a recipe? If the recipe calls for 6 servings and you want 3 servings, you cut everything in half. If the recipe calls for 6 servings and you want 24 servings, you multiply everything by 4. Same concept, using proportionality. Watch, I'm going to take 1 milliliter out of this purple stuff, and listen carefully. I'm going to put it into 9 milliliters of water, not millimeters, but milliliters. See any difference yet? This is 10% of this. So I took 1 milliliter here and put it into here. Now I have a 0.1 molar. And you don't see much difference yet. I'm going to switch instruments now. You're all going to get a chance to play with these during the semester. This is a micro pipetter. And I have to be careful about changing the tip. This I've already adjusted. It's measuring out exactly 1 milliliter. So I have another tube here. This I want to press down. There's a stop point. I'm going to pull it up. There is exactly 1 milliliter here. And that goes in there. Now I'm done with this tip. I'm not going to reuse it. See any differences yet? 1 molar, 1/10 molar. What's the molarity here now? Hey, I took 1 ml of here and put it into 9 mLs here. Counting down by tens. So a 1 molar solution, a 10th molar solution, a 100th molar solution. So far, so good. I'm going to take out 1 ml out of our 100th. What's our concentration now? This was 100th. This is now 1,000. By the way, the technical name for what I'm doing now, it's called serial dilution, diluting by a factor of 10. See a difference there now? I could do this again. I could take, well, you get the picture. The lavender color would get fainter and fainter. And by the time you're down to 100,000th, a millionth, you wouldn't see any color. All you would see was practically just the water. There would be very little solute. This is the same thing. I want you to visualize it using color that you're thinking about with sugars, salts, and other things that you mix in water. So a 1 molar, a 10th, a 100th, a 1,000th, a 10,000, and we can keep going down here. Now the concentration of sugar in your morning coffee is about a 1 molar concentration. The concentration of sugar in your blood is somewhere around 1,000th of that value, depending on what time of the day it is. Your blood sugar goes up or down. You don't keep much sugar in your blood. You keep very little sugar in your blood. So the concentration of sugar in your beverage is not anywhere near the same concentration as the sugar in your blood or your cellular tissues. So keep this idea about concentrations of molarities in mind, and we'll turn that off now.